We will now move on to integrals that require both integration by parts and u substitution. Usually it's u subs first and then integration by parts. But here's an example where you have to do integration by parts first and then do u substitution. So according to Lee 8, what should we integrate? X squared, right? Because sine inverse is an inverse trig function, so that actually has to be in this column, derivative column. Plus minus derivative integral sine inverse should be actually differentiated. Then x squared into raised to 1/3 x cubed. Oh, I should have asked you this. The derivative of sine inverse of x is 1 over square root of 1 minus x squared. But you knew that, right? Yeah. Okay. Now, as you see that if you keep differentiating, this will never reach 0. In fact, if it's not a polynomial, it never reaches 0. So whenever this column is filled in with something that's not a polynomial, the downside of a tabular integration instead of the integration by parts is that you need to know when to stop. And that's why some teachers do not like the tabular. They stick to the traditional method. I, on the other hand, is a fan of this tabular method. So let me give you a very easy way to remember when to stop. It's like this. Lee 8 is the one that we use to see which one goes here and which one goes there, right? Here, inverse trig was this one. X squared is a polynomial. Polynomials are algebraic functions, so it's this one. So that's why I is on the left side, A is on the right side. Now, when you have something that's not a polynomial in the D column, you just say, if your groups are involving these, anything from here, you stop at the second column, okay? If your groups are involving anything here, you stop at the third column. And that's it. You just have to remember that. Then you can always use tabular, right? So we use tabular, and it's because we're on here, we should be stopping at the second row. Now let's see what we get if we apply the tabular method to this, right? No sound effect. Right. I'm too embarrassed to do it myself, so you should do it. All right, and then what? Just like that, right? And then this last line has to be what? Multiplied and integrated, right? So we have a minus times this times this. I like to pull the numbers outside, so I have 1/3 and minus. I'm going to pull it outside the integral. And you have x cubed multiplied this is the same thing as putting this on the top. And therefore, the tabular integration says all I have to do now is to have this plus that, except that we still have to do this integral. Okay, now let's try to do that integral. We're going to ignore the negative 1/3 for now and just focus on this integral. Integration of x cubed over square root of 1 minus x squared dx. And this requires u substitution. And you have several options, actually. You can choose 1 minus x squared to be u, or you can use square root of 1 minus x squared to be u as well. And there may be some others. But the one I like is setting the entire square root to be u. So let's try this one. And because I don't like differentiating square roots, I'm going to square both sides. And then apply the d operator. D of u squared is, so remember, d of some function of a variable is what? you differentiate and attach that d of that variable. That's how you do it, right? So what's the derivative of u squared? 2u. And then what do I attach? D of u. And then what's the derivative of this? Negative 2x dx. Okay, once you have that, now what do?
Divided by -2.
You have to divide by negative 2x so that you solve for dx, right? So you want to say dx is equal to 2u du divided by negative 2x, and 2 cancels, there's a minus, so it's negative u over x du. Okay, so that allows us to change this integral. I don't know what to do with x cubed yet, so let's leave it like that. And then square root of 1 minus x squared, we decide to pull it as u. And then dx, according to this calculation, is negative u over x dx. And I see that u and u cancels. X cubed divided by x is x squared. Let's pull the minus outside. Oh, sorry, this was u, du. Okay, so you have integral of negative x squared du. Can we do the integral now? What's x squared integrated? 1/3 x cubed? Is that what we should do? No. That's a big no-no, right?
So
what must happen? Huh?
When we say equal x, x, we say do u.
Right. So what we need to do is you have to finish the u substitution. Are we done with the u sub yet?
No.
Not yet, because I still see an x. Okay? In fact, trying to perform the integration while still having the old x in there, that's a unforgivable sin. When I grade your exams, that'll be like very poorly. You won't get much partial credit if you do that. Okay, so don't ever make that mistake. Okay, you should never still have x in there and proceed to do any type of integration ever. Don't do that. Okay. All right. So we have to convert x squared into somehow u. How do I do that?
Well, we have the u there, so
We use this, right? What does this say about x squared? If I move the x squared here and move the u squared there, x squared is equal to 1 minus u squared. Okay, good. So I can rewrite this as negative integral of 1 minus u squared du. And now everything is in terms of u, and I can happily integrate. Okay. Therefore, this is going to be negative of u minus 1/3 u cubed plus c. Is that the answer?
no, you have to plug
Still not yet. Why?
you have to plug the u back in.
You have to plug in, what was it? U is square root of 1 minus x squared minus 1/3 square root of 1 minus x squared, the third power plus c. Okay, and now we can, since we figured this out, let's rewrite what this is. This is negative 1/3 times well, negative should cancel. It's a times negative of square root of 1 minus x squared minus 1/3 square root of 1 minus x squared cubed plus c. And negative 1/3 times this is positive 1/3 times this, so you get 1/3 square root of 1 minus x squared, and then 1/3 times 1/3 is 1/9, so it's minus 1/9 square root of 1 minus x squared cubed plus c, and you still have this, so now we have the final answer. So I'll just write the answer here. The answer is 1/3 x cubed sine inverse of x plus 1/3 square root of 1 minus x squared minus 1/9 square root of 1 minus x squared cubed